That's the probability of 1 success, 2 success, 3 heads. A success is a head in this case. 4 heads, 5 heads, 6 heads. What do you get when you add all that up? You get 0.305, 366, 388, 386, 387. Roughly, I think, correct? Double check me on that. 385, 366, 388. Oh, I'm off a little bit. 388, right? 394, 395. Thank God. You get 395? Okay. How close is that? I really desperately want you to understand what we just did. I used a normal distribution for a not normal thing. It was just approximately normal. And you can see from the histogram that it was approximately normal. We're going to kind of formalize that here in a minute. We should have a more definite way instead of just eyeballing it. Well, it looks normal. I think I'll do it. There's got to be some kind of a cutoff, and you know there is. So I did it using the z-score chart because it looked normal enough to do it. Cool. And then I did it using the actual thing it is. It's a binomial situation, right? I get heads or I don't. 2 possibilities. So that's the way we did it here. And look how freaking close they are. They will almost never be the same, but they should be decently close, as long as it truly is normal enough. So what tells you it's normal enough? That is a very central problem in statistics. If I didn't have a binomial, if I just had a mean and a standard deviation, how big of a sample would I have to take to make it the sampling means normal? What's the magic number? I have to take at least what, or over what sample size? 30. Cool. If I have an NPQ problem, what has to be true, let me see if you guys can get this. Do you guys still have it open on the table? Do you see how for a 0.01 probability, if you look it up in the table, n equals 14, p equal to 0.01, how do the probabilities go? Don't they go 0.86 something? 869? And then what?
0.123.
0.123?
0.008.
0, and then like down from there, right? So wouldn't that look like this? Here's 0. That'd be 0.869, 0.123, 0.008. Does that have any chance to be normal? No. Why? Because the damn thing starts high and goes low, and that's all it can do. Why is that all it can do? Why did this have a chance to be normal? What's its mean? 7. So it had room to go up and come down. This guy's mean, what would this guy's mean be? Who knows what this guy's mean is? How'd you get the mean for an NPQ problem? What's the formula? NP. And what's 14 times 0.01? 0.14, right? So what is the average for this problem? 0.14. So doesn't it make sense that 0 is the most likely thing? It's very hard to get a success here. 1 out of 100 times. So what's the most likely thing? You don't freaking succeed at all, right? A little tear. Woo. So the magic number, I hope you guys got to get this. If I pull this average out, if I pull it from that wall, am I not giving it room to go up and room to go down maybe, right? So if I just take that mean and I make it more than 5, that'll give it room to go up. Now looking at the other side, if I made the mean too big, if I made n equal 14 and p equal to 0.99, isn't it 0, 0, 0 until you get to about 12, 13, 14? It's going to be basically that, just the other way around, right? Now it's 0.869 here, 0.123 there, 0.008 there. If I make the mean too big, then it's going to have the same problem on the other side. Then it's going to go like that, and it's not going to be normal. So the way to take care of that is actually to look at NQ. If both of these are bigger than 5, that puts it right in the middle somewhere. That gives it room to go up and room to come down. It's that. That's all there is to it. I won't say it's that simple because I'm sure some of you guys are like, oh, what the hell? I really desperately want you guys to see. It's very, if the mean is too small, it slams into this wall. Because what's the lowest successes you could have? 0. So if the mean is too small, that's going to be the tallest bar. There's no way you can go up to it and come down. I've got to pull it out in the center. And that's exactly in the center, isn't it? Because I made p equal to 0.5 there, didn't I? Because I was flipping a coin. So that's exactly in the center. It's got room to go up and come down. And that's why our approximation was so damn good. Because it's really right in the middle. So if I have an NPQ problem and this is true, then it's approximately normal. Period. If you drew the histogram, it should look like a normal curve, like you could fit a normal curve on it. And if you wanted to, you could use z-scores to answer the questions, just like you could use p choose x, n choose x, p to the x, q to the n minus x, that whole formula, right? If, going back just for a second, just to make sure you guys are with me. So I know the formula for the mean, I know the formula for the standard deviation. If once I get those two, I can make a z-score no matter what. The one thing I need to be normal for is to get that probability, right? You could always make a z-score. You just can't look it up in the chart unless it's normal. So in this case, what told me it was normal? The mean was 7, and the failures, NQ, was 7. So they were both bigger than 5, right? That's why the approximation was so good. So here, what if I would have mistakenly not changed that? What if I would have left it at 6? Somebody help me out. What would that be as a z-score then? 6 minus 7 instead of 6.5 minus 7. 6 minus 7 divided by 1.871. .534? So like 0.53? Okay. And then if you look that up in the chart, we're going to get nowhere near what it's supposed to be. Look up negative 0.53, and you get an area of 0.2981. Is that anywhere close to this? That's what it's supposed to be, isn't it? By adjusting it by a half, I make my approximation so much better because I'm making my discrete data look as if it's continuous. So that's a little adjustment that you make. So I want you to be able to, so notice one thing. When you have to change the standard deviation, that's the only thing you do, and then you make z-scores like normal and you look them up, right? So the only change to the normal z-score thing was changing the standard deviation. Here, what's the only change to the whole process? Make the 6 go up or down by 0.5. All the other freaking steps are the same, right? Okay. So one last example, and then we're going to move on. Let's say I have, 8% of Californians think education is overfunded. I doubt that those include any students or professors, the people that actually know. So 8% of Californians think education is overfunded. If I take, we take a sample, we take, I don't know, 120 people. And I wonder the probability that more than, let's say at least, what, Jeff? I don't know, Jeff. 11 people think so. Now, real quick, can you imagine, what would you have to do for the formula? If you did it exactly like this, you have to do 11, 12, 13 up to 120. So you'd be smarter than that. You'd say 1 minus the opposite, which is still 10 calculations. Okay, that's crazy. I don't want to do 10 freaking calculations. And your teacher won't let you get the answer from binomial PDF, right? So too bad for you. So what we have to do then is use this approximation. So the name of what we just did over there is the normal approximation, which makes sense because I'm approximating a binomial with the normal. Normal approximation to the binomial distribution. Oh my God. So I just call it the NAB. So now you guys know on that last practice test I gave you, I had a problem that referred to the NAB. That was it. I just hadn't made it that far to that point, so that's why it wasn't on the test. So here's what you do. You first, did I tell you the mean and the standard deviation? You very quickly calculate it for yourself, right? And those are nice little formulas. So what's the mean? How do I get the mean?
120 times 0.08.
Yeah, 120 times 0.08, which is 9.6, cool. And the standard deviation is square root of 120. That's 0.08 times, what's Q? 0.92, I love it, the rest, right? 8% there, 92% there. 2.973? Sounds about right. Bless you. Say again.
2.971.
Ooh.
Oh,
You got it?
oh, that's a little.
You're on
I thought it said 921.
Oh, no,
I
sorry.
was wondering why you put the 1 there.
My bad.
I did it anyway.
971?
Yeah.
Okay.
We're rounding up to 2.
Hmm?
2.9718.
Oh, 1.8, so it's 2? Alright, we'll get this eventually. You guys gotta help me out, man. So normally in a z-score problem, I would give you these. Well, it's really quickly to get those. So now, why am I allowed to use z-scores? I already have one answer. What's got to be true? NP's got to be bigger than 5 and NQ. Which one do we already know? NP is 9.6. So that's bigger than 5. Check. NQ is going to be the rest. P is the probability of success. So NP is how many successes I expect. NQ must be the rest out of 120. So it's going to be 110.4. And sure enough, what is 120 times 0.92?
What'd you get 5?
That's the rule. Just like the 30, right? Just like the sample size has got to be greater than 30 to be normal. I've got to put it in a point where the mean is at least 5 to give it a good chance to go up and come down to be normal, right? That's the idea. Why is it exactly 5? I can't get into that math at the moment, all right? 110.4, cool. These have always got to add up to be 120. I mean, in this case 120, but they always have to add up to be the whole thing, right? Check. So this step here tells me what exactly? What does that step by itself tell me? That it's normal enough. It's approximately normal. Normal enough for me to use that chart. That's all I care about. So a big part of statistics is, given my situation, what am I allowed to use? So now we know, right now, we hope to God we're allowed to use that because that's basically all we know, right? So please, let me use it. So here, yes, normal enough.
Yeah.
So really the only thing, I can draw my picture. I just have to realize what I normally do is this. Draw my picture, what goes right in the middle?
The mean.
Which is 9.6. I want to know greater than or equal to 11. The only new thing I do is I put a little box around there. What's this side of that? And what's this side of that? Which side do I want to shade from? I want to go greater than or equal to, so I want to go up. And do I want to start there or do I want to start there? I like the way I said that. There. You can't go wrong. Do I want to start at the lower or the upper side? Do I want to include 11?
Oh, yeah.
So I want to make sure that this gets shaded, so I better